Day Data Science Challenge. Today we're going to go over NumPy. This is a library in Python. It's used for scientific computing. It basically works with multi-dimensional array objects and used to handle large amounts of data. An array is a grid of values and is indexed by a tuple of non-negative integers, which is a main data structure of the NumPy library ND-array, which is an acronym of the n-dimensional array. So to import it, you just import it as NP. There are arrays that you can have. So this is an array made here, 1, 2, 3. There is something that's called zero arrays. So basically it returns a new array setting values to 0. It does this 12 times. You can also have zeros arrays with an integer type. So here there's an integer type of 0 here, but it's listed 7 times. You can have ones arrays. So notice how this part is changing, zeros, ones. So this is just printing out 1 5 times. This is printing out a matrix. It's printing out 1 5 times in 3 rows. And then you also have full arrays, which returns a new array of given shape filled with a specific value. So you have 3 rows by 6 values in the columns, and then you have the number 9, which is part n. There's also an identity matrix. This is something new for me. I've never seen this before. It just np.I. This reminds me of the linear algebra classes. So it has 1 going diagonally across each, and that 1 is just moving along. You can reshape the arrays as well. So this 1 to 15 array can be reshaped. So basically it does 1 to 15. It gets all the values, but it splits it into 2 rows and has 7 values in each. You can see that it goes from 1 to 7, then 8 to 14. And you can also have an arrange and then reshape this array over here. So it basically went 1 to 10, but then it went 1 by 1 values for 9 values in one row. Okay, flattening the arrays. You can convert multi-dimensional arrays into 1D arrays. So basically you can rearrange this 1 by 9 to 1 by 8 and reshape it from starting from like the -1 is basically like an indexing. It starts from like the back side of the array, but not really sure what it does here. It just printed out all the values. It looks like it was supposed to go from 1 to 9, and then it reshaped it to 1 to 8, so it just cut off the 9. And it's saying cut off on the backward side, so basically have the 8 values but cut the 9. If it was +1, maybe it would take out this one over here. Concatenation basically combines together 2 NumPy arrays, and it's using these 2 arrays and putting them together. So it goes from 100 to 140 in the first array, and then it goes from 120 to 220 in the second array. So it just combined it. And then we also have the other array over here, which is basically going from 10 to 60, and then 101 to 1 to 6, and then it's just combining those two. And then you have broadcasting. So what is broadcasting? It's a powerful mechanism that allows NumPy to work with arrays of different shapes and when performing arithmetic operations. If the arrays do not have the same rank, they prepend the shape of the lower rank array with 1s until both shapes have the same length. The 2 arrays are said to be compatible in a dimension if they have the same size in the dimension, or if one of the arrays has size 1 in the dimension. The arrays can broadcast together if they are compatible in all direct dimensions. After broadcasting, each array behaves as if it had shape equal to the element Y's maximum of shapes of the 2 input arrays. In any dimension where one array had size 1, the other array had size greater than 1, the first array behaves as if it were copied along the dimension. So basically you have this array 1, 0, 1, 0, 1, and then you have this array 1, and it looks like it added 1 to each of those values, so it became 2, 1, 2. In the scalar product, we have 2 equal length sequences of numbers, and it returns a single number. And then you have this NP array here, 30, 15, 19, 42, and 101, 90, 45, 64. I think it either multiplied the numbers. If you do 30 by 101, it gives that. 15 by 90, it gives that. 19 by 45, it gives that value. Then 90 by 64 gives 4398. So yeah, I guess this is the lesson on NumPy arrays. Thanks for listening.